Okay, we're ready to start, I think. This is great. I'm so glad so many people are here and ready to present their presentations, so to speak. First up is Dennis. I'm going to hand you the microphone and let you present.
Hi, everyone. So I have two demos, actually, and the first one is on the... two times. So the first one is... I guess they're both on the Insights, actually. But I've been fairly unsatisfied with how on the Insights you go to the videos, and then you have to drill down sections and subsections and so on. So this is the kind of Insights page as it is, and these are video views, and to get down to see the actual timeline, you have to click into it, or you have to select a section, then it takes you into the section, you have to click on the subsection, and eventually click on the subsection to get to the video. And this is a video timeline showing video views over the length of the video. So what I wanted to try to do is flatten out that list. So show all the videos on one page. And my first attempt looked like this. So this is a table, and the timeline data is stored as an array. But I wanted to turn that into a graph. So I created this here. So it's still the video page, but instead of every section that's listed in the table, I'm showing all the individual videos. And you can see that these are each row is an individual video, and then there's a completion percentage, and then a little spark line that shows the video viewage. So I think that there are some kind of interesting things that pop out. So this video is like pretty long, and the completion percentage is sort of small, 69%. This one has an interesting mountain kind of twice, and you can click on this to open it up and to get to the actual video page that we used to have like 3 or 4 clicks to get down into. And so you can see here, these sections of the videos have been replayed fairly often. I think I saw one video in which the instructor was mumbling a lot, so I think people are scrubbing there. So I think we could do similar stuff for other pages too, because our performance pages group modules by sections and subsections as well. Kind of like this. And I think that we could probably use like bar charts or some other sort of sparkline-y thing to bring up the data to flatten out some. And I do have one. So the course I showed you was a fairly small one. This one has 194 videos. So there's a lot, and I have some rendering issues with the rows, but it is kind of cool. Like you can sort by completion percentages. You can see that we have some data issues happening here. One user has watched it for like an hour, it looks like. Yeah, it's okay. Don't worry about it. So that's demo 1. So my demo 2 got a little bit ambitious. Oh, thanks. So my second demo, I wanted to do the same thing that I did for videos for the whole course. So the videos are basically modules, and I wanted to show all the data that we have for every module on one page. So what I did was I created this heat map, and I don't know if you can see it too well, but basically we have colors ranging from kind of light red to orange to dark red, and this corresponds to percentages. So for videos, this is percentage viewed. For problems, this is percentage correct. So in this course, I don't think I have any problems. So each of these columns represents a problem type or a module type. So videos is this column. The second one is graded content. The third one is ungraded content. So the colors here just correspond to how much of the video was viewed. And then I have a second course here that has a lot more content. And you can see video viewage and then problems complete. I think I saw some kind of cool ones here, like this one. This problem wasn't completed very well. You can kind of view all of it. It is one page. It's a very long page. And then I wanted to like play with ordering of stuff too, but I didn't get around to it. I did implement reordering, so you can click on it. It animates. But I think it could be fun to like maybe order by completion percentages or problem completion percentages. Maybe the hackathon number 14. That's it.
So I made a course on how to contribute to the Open edX documentation with this beautiful image that Liz Cohen made for me. And it walks people through. I can make that bigger. Walks people through for a very non-technical audience who we hope to encourage to contribute to the documentation, how to find the source files and get themselves set up with a GitHub user account, introduce even the concept of GitHub for people who might not be used to it. The first video I made, you create a user account.
Demonstration. See how to get started using GitHub as a hosting service. edX uses for all the documentation.
And then another section on getting around in GitHub about the edX repository and the authors file. And your first commit and pull request are adding yourself to the authors file. So the rest of it I haven't built out, but I have different topics that could be interesting to people who want to contribute, and maybe we'll be able to work on this support.
Okay, there it is. I wanted to take a look at our CSS. That's it. This is going to be a mini tour. I basically did two things. I did first a static analysis, and then I moved into some dynamic analysis. Essentially, I wanted to take a look at how much the users need to download to see our styling, and whether or not they should be downloading all that stuff. This is a free service, CSS Stats. You can see we have almost 5,000 selectors in our CSS. It's just fascinating stats on the number of fonts we call, number of colors we call, 350 colors. And there's sort of a specificity graph and rule set size. So there's definitely a lot going on in CSS. I focused on LMS main, which is almost a meg in size. And this is basically how I envisioned the work I was doing, which is we're trying to squeeze this big book thing through a small. So we can remove redundancy on one hand, where there's a lot of repetition of unnecessary code, and then we can remove code that we're not even using, styling. Right? I used a tool called Analyze CSS, where you can just pass in one CSS file, and it'll break it down. And we had a lot of issues to work on. Here's an example of redundancy, right? Where that could potentially be collapsed. There's repetition there. You're calling out the color twice. You're calling out similar selectors. So I took some time to look at minifiers. We don't specify a minifier on platform, but that's not because we're bad people. It's because SAS minifies it for us. But I did some analysis on post processors, and this is a grid I can share later. One that is the Python-based one you can get Django, add to the Django static pipeline, actually had no difference, the exact same size. That was kind of fascinating. But the best I could do was squeezing out 4.82%. That's running a couple of post processors. CSS. So the next question is actually not trying to squeeze it through the door, is to just leave it on the platform, not bring all of that CSS with us. So I wanted to analyze how much of it we're actually using. That's actually harder to do because the way we optimize our CSS is we ship it all at once, as opposed to each page having its unique CSS file, which is kind of a smart way to do it. It makes it a little harder to determine how much we're actually using. So you have to kind of look at several pages. There's not a ton of tools that do that. But cursory look tells us that we're not using somewhere in the 90% or more of our CSS. Okay. This is another service I use called Test My CSS that some that's similar kinds of tools. And then I just love experience.
Hello? There we go. Hey. So we've been working the last couple of months on the release pipeline with the Go CD. One of the things that's not very great about it is that if you want to build your pipelines, you can either do it in this amazing XML structure that's right here, and we all love XML, or even better, you can go in through the pipelines here themselves, and you can edit them, and you can click through the interface, which is my favorite. So one of the things that I wanted to do here, and we've been talking about as a team, is we want to get rid of this and move into more of a DSL to begin building these pipelines. So actually for like the last maybe week or so, this has been my main focus, and I just want to show you guys a little bit of this today. So the big takeaway here is, so there already was another team working on a DSL. It had a few defects. It did support HTTP authentication, which we had to add in, and a few other things, and also the scripts that were being generated out of DSL when we were reverse engineering scripts was not very good. So I've been working on all three of those points. And just to give you guys a quick, or to give everybody a little quick look at what one of the new building pipelines looks like, is you have these very small code snippets. I've also been working on making a lot of this code much more dry than it was, so we're not repeating ourselves continuously throughout the pipelines. And then also trying to hide all of our secrets so that we can make these scripts publicly available and not have to hide them in a private repository. So just real quick, really just coming down the right pipeline now. It has more of a called Ansible type of syntax. When you call from the command line, you can specify multiple variable files as well as individual variables on the command line. And when you want to set up a pipeline here, call the scripts, generate it, runs, and then your new pipeline has been created and does all it's supposed to do. That's it.
All right, we'll get my screen set up here. Hold on. Maybe. I only have a mouse. There we go. Okay, so this is Kodi. It's an open source media center that I use at home a lot. It's a way to watch videos on your TV. Doesn't like display, which is super fun. It's not working on the display for some reason. Hang on a second. So this display is not going well, but the upshot is this lets you browse videos from various streaming sources, and I made a plugin so that you can get your course videos from courses you're in and watch them on TV. It'd be super cool if I could show you, but that doesn't seem to be working. Can you unfull screen it? Yeah. It's a setting in the system, like in the software, that I can't navigate to. It might be. And it worked. My screen's different now. Anyways, that's what I made. It's cool. I'll show it to you on my laptop sometime if you want. Yeah.
Okay, so I worked with Allison on our hack, which was to upgrade the linter that we're using in a couple of the libraries or the repositories that we have that do JavaScript. So currently in UX pattern library, the UI toolkit, the edX platform, and a couple other repos, we're using two different tools in order to lint our JavaScript code, which is to check for syntax errors and before they get into the browser, hopefully. We're using JS Hint and JS CS, both of which are tools with sort of overlapping functionality. Obviously, it's not ideal that we're using two tools to do what one might potentially do. And then the other issue with that is that recently, JSCS announced that they were going to end development on their project, and they're going to all of their developers are going to go join a team of ESLint, which is a third tool that's gaining a lot of popularity in the JavaScript community right now. So what we worked on was moving several of our repos to ESLint and coming up with a new linting configuration for ESLint that expresses the way that we want to write JavaScript. This is the homepage of ESLint. ESLint also has the benefit that it supports ES6 really well, which is sort of the next generation of JavaScript that we're going to hopefully start using pretty soon. So the first thing that we did is we took our existing JSCS and JS Hint configurations and ran them through this tool called Polyjuice, which can convert between all three of these tools a rule definition DSLs. And we got an ESLint config that looked a lot like the config that we were using before. But we actually wanted to go a little bit farther because a discussion that we've been having among sort of the front-end guild recently is that our style guide isn't as specific as we'd like it to be, and we'd like to start having a beefier set of rules and styles that we use when we're writing JavaScript. So we looked out community for some examples, and one of the great things that several people had actually used before at previous jobs, including myself, Allison, is the Airbnb JavaScript style guide, which is sort of growing to be this community standard. It's really well documented, and it's the most popular ESLint style guide based on downloads from NPM. So we decided, why don't we just extend it? We can use the Airbnb guide as sort of base, and then we can layer a couple of our own rules on top of that. So we did that. We created a new style guide called the ESLint config edX, and I wrote some documentation for it. So you can see here, the config extends the Airbnb JavaScript style guide for ES5, and then we have about 10 extra rules that are just based on sort of our own styles that agree with theirs, or sort of quirks of our platform, including our usage of require.js and Jasmine and some other things that Airbnb is not using. So this is really easy to install into any new repo or existing repo that uses JavaScript. You could really do it in 3 lines. Did that to, oh, here's our pull request where we're just sort of talking about some of our rules. Yep, wrapping up. It's an NPM installable package, so you can just drop it into any of our repos, which we did to the UI toolkit. and to the UX pattern library, which Allison handled. So here, I'll just give you an example of running it toolkit. Didn't completely get through fixing all the errors. There's about 70 problems here, but a lot of them are pretty easy, repeated things to fix. And here's an example of what it looks like in the editor. ESLint has really good integration with Atom and with PyCharm. So here's a code that has some linter issues, and this link right here is actually a link right to the ESLint documentation, which basically shows you how to fix this problem. So we're pretty happy about having more thorough and more usable linting all of our JavaScript.
Hello. So we worked on embedding Book into edX. Book is a platform that I worked on, and so I'll present that first, and then we'll show some of the work on integration. Book is a platform for enabling nonlinear learning, and that shows connections in a course that you would not otherwise see. I can show you this quick YouTube video. So we have a little course here that is the one we worked on to make this platform. And for example, if you're interested in learning about likelihood ratio, you can set this as your learning goal, and then it will flag it for you, and then you can see these are the things that you have to do. You have to do these first 3 concepts within tiers of inference, and you can skip all these other concepts within tiers of inference. You have to do these few here, and then you can skip model dependence. And so this is the path that you have to go on in order to learn the minimum that you need to know in order to learn likelihood ratio. And then you can go in and see all the different materials that the platform has on that topic. The way you get this is by going into the admin interface. And just typing stuff one after the other. And then you create dependencies by drawing arrows like this and going lower and lower. So we presented this last week at, right here actually. And some people liked it, so I was invited here to try and see if we can include this into the edX platform. However, the idea of clicking around here and importing materials was not well received because then you would have this overlap between edX and this platform. So our goal was to integrate this with edX while using the existing structure that edX has. So we wanted to detect the X blocks that edX is running and automatically display them on that map as if you had created them manually. And so we were working on making an X block, and this is our first book X block that you can include in your course.
So this is running in the LMS, but we're just looking at the Book X block itself. You can see up here in the URL. And this is getting the information from the demo course. So these are the different chapters in the demo course. And the data is being pulled through the XBlock handlers. So we can click and zoom in to the different parts of the course. And then, for instance, this is one of the videos within the course. So the part that we were working on was the XBlock navigation in order to, the XBlock, pulling the data from XBlock of the course structure. We didn't yet get to the point of actually being able to declare the dependencies between the different portions. So you're just seeing the path through the course as it's structured, and you would see it right now in the LMS.
Yeah, that's basically it. So everything is pulled automatically, and we will, with little more work, we will be able to add the dependencies on top of this. So then we'll be able to go in and out of this visualization while still being in your course and navigating your materials with this interface. That's it.
Hello. So I'm John Eskew, those who don't know me. What I did, the hackathon, I hacked alone. And so you might be aware that our LMS in Studio runs on Django. And recently, within the last year, we converted from version 1.4 to version 1.8. It was a long project, involved many engineers. And a lot of people contributed to that. So we're on 1.8 now, but 1.9 is out. And my project is to kind of ask the question, well, what's it going to take to get us to 1.9? So really, actually, I did this project for one reason alone, and that was to, you might have seen this error before. Actually, you might have seen it hundreds of times. I have a branch that gets rid of this error now. So, yes, yay. Unfortunately, I have to wait on comprehensive theming to go out first. But they promised me that's very soon. So, because they've changed Django Wiki also. So, anyway, that will be done soon. So the main thing that I found out when I started down this path was that big change in Django 1.9. It does not allow you to import models inside of your init. So we do that in a lot of places in the edX platform. So that had, I had to change that 5+ modules, and I actually cloned my first Bitbucket repository today and used Mercurial for the first time. So it's exciting. Yes, but I got to the point where I could migrate, I could run migrations. Of course, it's spewing out a lot of deprecated errors and a few other exceptions. But I made some good progress today, and it's a good start, to actually doing the work. But the one takeaway is that in 1.9, we'll not be able to import models inside modules. So we're going to have to kind of restructure the way we do that. And that's it.
Test. So I decided to make an SVG exe that you can edit. By default, we can have him happy. We can have him sad. If he's sad, we can give an image, import a custom image, and then position it with. And then he becomes happy. Oh, I lost it. There's also some other images. We can give him a guitar. We can give him a Nickelsack record. All of these fields are completely editable for the colors. So here's one I made earlier. And, oh yeah, we can make, but the most important thing is we can take sad exe and make him happy.
It's actually on the wiki page. It's on the wiki page? Yeah. Awesome. Yes. I don't know how I'm spending my life. Use this thing? This is cutting it. So just clip it on. Yeah, no, I saw it. I'm actually trying to get it to run locally. Six? Yeah. I'll just a little bit. Yeah, exactly. You saw Alice, the one that Sarah. Oh, this one. Oh yeah. The Halloween XE. Dead XE. Dead XE.
Hello, hello. Oh, great. Yeah. Yeah, so Brian and I wanted to do some natural language processing on the plethora of text that we have in course content. Fortunately, not all the text was super readily available, so we ended up working on a very small subset, just maybe about 150 courses video transcripts. So ideally, we would have a lot more text and do really awesome natural language processing things. But the thing that we did do that was kind of interesting was some top modeling. So we ran these transcripts through an algorithm that sort of gave, if you could specify how many topics you want to get out of it. We said actually 20, and you can kind of see what topics are. So a lot of the Chinese characters they grouped together, which is pretty good. But you can see things like topic 6 is voltage, circuit, current, source, resistance, resistor. So it really picked up on these electricity things, but otherwise you saw stuff like emperor, Chinese, China, Mao, energy, electrons, orbital, silicon, so it did a pretty good job of mixing things up. But anyways, it was a pretty fun project. That's all.
Hello. Test. Oh, you have HDMI too if you wanted to use that instead. But I would use this. It's not cutting out. Oh, okay.
Hello. Hi, I'm Tyler. So all of these lovely people worked on bok choy, showing some love. We had a lot of tech debts and a lot of issues that we wanted to resolve. So what we started out with was these issues here. We wanted to deprecate the HAR capture. We decided the browser APIs for network performance monitoring were better than what we had in bok choy. And we wanted to package wheels and distribute on PyPy. We wanted to update the Firefox driver. Oh, by the way, bok choy is a UI level acceptance test framework written in Python, for anybody who didn't know. And so we wanted to update the Firefox driver that we were using to run the tests to use the Gecko driver Marionette, because the existing one we had that Selenium used required a very specific old version of Firefox. And we wanted to fix some confusing issues with try limit, and we wanted to add Python 3 compatibility. And
just by the way.
Yeah, just by the way, like. And we also wanted to, so when our tests failed in bok choy, we save a screenshot of the page when that test failed. And we also wanted to save a HTML source, which could help debug the issue. And so this is the PRs that we got. So big list. So from the bottom up, we took out the HAR capture feature. We upgraded edX lint to the latest version, or edX lint, sorry, yeah. And we added Firefox profile path. So this would allow you to override the Firefox profile that Selenium uses to run the tests. And we upgraded to Pycode style, which is the newest name for PEP8. And we upgraded to using Tox, which is a test runner. And that allowed us to clean up a lot of code we had like a shell script that would run the tests. So that was a lot nicer. And we also cleaned up the requirements, made a new release, added the HTML saving, upgraded to PyTest instead of nose, and added some docstring explanations, Python 3 compatibility, and yeah, we also upgraded a lot of dependencies and improved our test coverage. So we got a lot of tech debt done in this hackathon. And yeah, that's it.
So we're officially moved from alpha to beta. We're releasing 0.6, and then we'll be releasing version 1.0 as soon as we get all this stuff ready and set up .py. We've got the wheels already up on PyPI for version 0.54 in the process for always uploading wheels. And yeah, then we're going to move to 1.0 and start really blasting this out across the community as a very helpful Selenium-based UI automation tool. And I have to say myself, like, I was going to do like a couple of these things by myself, and I'm skillless, like, so blessed and happy that like all of these guys were like, yeah, we got to do this, and joined in, and we kicked it out, man.
There we go. Okay, so I decided that I wanted to take the time during the hackathon to teach myself a little bit about React. It seems to be all the rage right now, and I was not familiar with it. So for context, this is a mobile game I really like to play called Letterpress. I'm not that good at it, and decided that I was going to build myself a little tool to help me out. So the name of the game is called Letterpress. The tool to help me out is called Typesetter. Let me make this a little bigger. It's pretty simple. Basically, let's say you've got the letters A, D, and P, and would like to know what letters you can create on the board. So A, D, and P, and you get back this nice list of words that you could play in the game. And I've got something else cool to show. 1 second. All right, so this is the CSS on the left here. This is an exercise in using a live reload server as well with Flask. So let's say that I want to change the border on the input element on the right to have a dotted outline. So I just make my change here and save that, and it refreshes instantly in the browser on the right. And so going forward, I can use this during development to ease the process. And half of my project was getting that working.
Want to present? Did anyone else? Anyone else? Then we're done. We can just enjoy. Oh. All right. Stu, a late entry.
There we go. Okay, so this is not going to look like much, but it was an interesting learning process. Where's the HDMI cable? So the general idea was that we wanted to take a query language, and we chose GraphQL, so that people could write somewhat API-agnostic queries against an API. And we wanted to use Haskell to take Swagger documents from these APIs and do a bit of meta-programming and take the Swagger docs and generate the bindings to GraphQL. So right now it's not exactly the most pretty right now because we have a simple Haskell server running that you can right here. Maybe I'll just clip it. I'll just hold it. So you can run curl statements against it using a simple query like this. We just say we want from catalogs we want name and course count. And
Can you change the font size?
oh, sorry, that's really hard to read. My bad. Zoom in. Do that again. All right. So just running this Haskell server on localhost, we can send a basic query. And in this one, the only thing that we created bindings were for the catalog API. So we can get name, course count, a few other things. It's a little hard right now because we were hand coding the bindings. So taking things from SwaggerDoc and then taking a Haskell implementation of that. But we began using something called template Haskell, which allows you to feed it something like, say, a SwaggerDoc or some other type of generic documentation, and essentially have the Haskell generate the Haskell that would be the binding for it. So once we create enough of these functions, then it would be not trivial, but we could essentially load more documents. And every time we change SwaggerDocs, we could just put it into this document directory, recompile the server, and then you can make queries across any of our APIs. It's kind of like a one-stop shopping. So that is it, and I don't know if this will be make any sense. Let me pardon all the errors. Okay, this is something that Kale got together in the last little bit, in which running some functions right now, he's completely created Haskell on the fly. This is all at compile time generating code that's based upon an existing Swagger doc from the Stage API. So essentially, you could then create new Swagger docs and it will generate new code bindings. So you won't have to go in and change anything. And like I said, it was an interesting learning experience.